You know those math concepts that just seem impossible? Well, today we're tackling one of the big ones. We're going to crack the code on a tool that's super powerful, but honestly often misunderstood. I'm talking about the logarithm. So let's just dive right in.
All right, let's start with a little thought experiment. Picture this, a whisper. Now, picture a rocket launch. How in the world do you measure those two things on the same scale? I mean, one is incredibly quiet, and the other is just unimaginably loud. They're on totally different planets, right? So how do you even begin to compare them?
Well, the answer is actually pretty elegant. It's a mathematical tool called the logarithm. Think of it like a translator. It's designed to take these massive, wild ranges of numbers and kind of shrink them down to a scale that we can actually wrap our heads around. It's what tames the beast of exponential growth. Okay, so we're moving into where you actually see these things. And trust me, you'll be surprised. This isn't some dusty concept just for mathematicians. Nope, logarithms are literally hiding in plain sight, working behind the scenes all around us every single day.
I mean, they're the backbone of so many different sciences. Take chemistry, for example. You ever heard of the pH scale? For measuring acidity? That's all logarithms. They also help chemists figure out how fast reactions are going to happen. Then you jump over to physics, and they're absolutely critical for modeling things like radioactive decay, which, of course, follows an exponential curve.
All right, so we get it, they're useful, but what is a logarithm, really? Let's break down the two main types you're going to run into.
First, you've got the common logarithm. It's just written as log. This is kind of like the default setting on your phone. If you see log and there's no little number next to it, it's always asking the same question. Hey, 10 to the power of what equals this number? It's all built on our good old base 10 system that we use every day.
Then we have its slightly more exotic cousin, the natural logarithm, written as ln. Now this one doesn't use base 10. It uses a really special, famous number called e. And e is a bit like pi. It's this irrational number that just pops up everywhere in nature, especially when you're talking about things that grow or decay over time.
So let's put them side by side. The key difference is pretty clear, right? The common log, is our base 10 workhorse. You see it a ton in fields like chemistry and engineering. But the natural log, ln, with its base e, that's the go-to for physics and biology, because it's so good at describing how things in nature actually grow and change.
But here's the really cool part. They're not totally separate things. You can actually convert between them super easily with this one simple formula. So if you know one, you can always figure out the other. It's like they're just two different languages talking about the exact same concepts. Okay, knowing what they are is great, but the real magic happens when you start using them. So let's open up our logarithm toolbox and check out the 3 essential tools inside that are going to help us simplify some really complex stuff.
Tool number 1, the product rule. Pretty straightforward. It just says that the log of two things multiplied together, let's say a times b, is the same as adding their individual logs together.
Yeah, think of this as the combiner tool. It's awesome because it takes a potentially messy multiplication problem and turns it into simple addition. And let's be honest, adding is way easier than multiplying, right?
Next up in the toolbox, we've got the quotient rule. Same kind of idea. The log of a division, a divided by b, is just the log of a minus the log of b.
We call this one the splitter tool. And just like the last one, it takes something that can be a headache, division, and turns it into simple subtraction. You're probably seeing the pattern by now, right? Logarithms are all about taking complicated operations and knocking them down a peg to something much easier.
And for our last tool, we've saved what might be the most powerful one for last. This is the power rule. It says that the log of some number a raised to a power n is just n multiplied by the log of a.
This is the lever tool, and seriously, it's incredible. It lets you take that annoying little exponent that's floating way up high and just pull it down like a lever, right to the front where it's easy to deal with. This one move is an absolute game changer for solving equations where the unknown is an exponent.
Okay, that was a lot of theory. Let's make this super practical. We're going to look at a quick reference guide now. Think of it as your own personal logarithm cheat sheet with some of the most common values you'll need to know.
This is definitely a slide you might want to pause on or grab a screenshot of. Just look at some of these. The log of 1 is always 0, doesn't matter what the base is. And check out these cool relationships. The natural log of its own base, e, is just 1. And the common log of 10 to some power, it's just that power. And having those rough values for the logs of 2, 3, and 5 memorized, super helpful for doing quick math in your head.
So, we've gone through what they are, where they're used, and how to use them. But what's the big takeaway?
What's the master key to really getting logarithms?
It really comes down to this. Logarithms aren't just some random abstract thing in a math book. They are a master key, a practical, powerful tool that lets us unlock and understand all the exponential relationships happening all around us, from the sound of a whisper to the decay of an atom.
So I'll leave you with this question to chew on. Now that you have this key, what are you going to unlock with it? What hidden patterns, what massive scales are you going to see differently in the world now? Just something to think about. Thanks for joining me on this one.